Hello and welcome to my OCR AS chemistry tutorial on organic chemistry. So organic chemistry is the study of carbon-based compounds, and there are lots and lots of different combinations of the carbon-based compounds, but all of them have one thing in common. They contain carbon and hydrogen, but only if they are called hydrocarbons. So hydrocarbons are organic compounds that contain carbon and hydrogen only. And a saturated hydrocarbon is a hydrocarbon with single bonds only. Single bonds only. An unsaturated hydrocarbon is a hydrocarbon with carbon atoms joined together in straight or branched chains. And an alicyclic hydrocarbon is a hydrocarbon with carbon atoms joined together in a ring structure, like this compound here called benzene. And a homologous series is a family of compounds with the following properties. They have the same functional group, same chemical properties, and each successive member of the homologous series differs by one carbon and two hydrogen atoms, or a CH2 group. This is what they look like: C, H, H, and that's it, CH2. Alkanes are saturated straight-chained hydrocarbons with single carbon-carbon bonds only. A tetrahedral shape of 109.5 degrees in each carbon atom leads to a crooked structure that looks like the one below. So, if we take a look at what one looks like, this is methane, and if I just show you the bond angles, it is roughly 110 degrees. It's very clear to see. If you actually got a protractor and looked at it, then you'd be able to measure it, but you can't, since these atoms are so incredibly small. Anyway, that's a more visual representation of this shoddy diagram that I had down here. So it's one carbon atom bonded to four different hydrogen atoms here for methane, and it's the same with butane if we look it up. If we have butane, this time it's got four carbons, so originally it was methane, but instead of having another hydrogen atom bonded here, we have another carbon atom with another two hydrogen atoms bonded to it, and another two atoms bonded to this one, and to finish it off, three hydrogen atoms on here. Now, why is this? Well, this is because of carbon's tendency to bond to four different atoms. Because carbon has four outer electrons on its outer shell, and it bonds to four different atoms. So in this case, this one can bond to one carbon here and three different hydrogen atoms, so that's satisfied. You can't bond any more atoms to it now. And then if you have this carbon here, it's bonded to one carbon here, another carbon here, and two more hydrogen atoms, and it keeps going like this until the chain ends, where another hydrogen atom bonds onto the carbon that has where there are either no carbons present, or there are no carbons present, so another hydrogen atom just bonds onto here if they are around. So if we look next part now, looking at how to name these hydrocarbons. Now there's a table in the textbook that goes all the way up to the number of names for up to 10 carbons, but I've written the first four down. So the first four go methane, ethane, propane, butane, and then 5 is pent, like pentagon, 6 is hex, 7 is hept. These are all the Roman prefixes. and 8 is oct, 9 is non, and 10 is dec. The reason why I've just written the first few letters of the word is because you can have different kinds of hydrocarbons. If you have non-ane, for example, then that means it only has carbon and hydrogen atoms in it. It is a hydrocarbon. But if you have non-ene, it means it is not saturated with hydrogen atoms. It has at least one carbon-to-carbon double bond. The carbon-to-carbon double bond looks like this. That's when two of carbon's bonded electrons are bonded to the carbon atom. Where there are no hydrogen atoms in excess, carbon atoms tend to do this. So we'll have a look at how to name this one. So we're going to count our carbons first. Carbon 1, 2, 3, 4. Now we're looking for any functional groups like OH, CH3, or COOH. You'll learn more about carboxylic acids later on in my tutorials, but so for now we'll ignore COOH, but these are just examples. So you then look for any functional groups. In this one there are no functional groups, there are no OH or CH3 or COOH, so we just look up on our table for the start off with the fourth prefix, bute. So we write bute with a little hyphen. If when you get started, it's best to put little hyphens in, and when you get more confident, you remove the hyphens. So since it's completely saturated, it is butane. Butane. Now that one was an extremely simple example. So if I do a little bit of meddling now with my carbon and hydrogen atoms. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Have one more on that end. So this particular one would be propene. So if we count our carbons again, 1, 2. Notice I'm starting from the functional group, the double bond. Double bonds can also be classified as functional groups, as they change the way the atom behaves chemically. And now, so I don't mess this up, you write down where the carbon-carbon double bond ends. So in this case it'll be 2-propene, because the carbon-carbon double bond ends at carbon 2. And since we don't have any other functional groups, we just leave it like that, 2-propene. So move on to naming it with functional groups. I've got more examples in this next part here. So I've got my table here. So we previously looked at alkanes and alkenes, and their suffixes are ane and ene. But if you want to bond any halogen in period 7 then they have their own prefixes: fluoro, chloro, bromo, io, and iodo. Remember these, as they're very, very important if you have halogens. If they're an alkane, then you use ane, but if they have a double bond, which is highly unlikely, then you will have ene. And for alcohols, you have a prefix if there's a hydroxy, if it contains, like hydroxide. Anyway, and a suffix O. For aldehydes, you have the CHO bond, and the suffix is al. Ketones look like this, and they have the prefix -one. And for carboxylic acids, COOH, they just have the oic acid on the end. Going back to the hydroxy, had a bit of a blank there. So you can use the prefix or the suffix, but commonly you use the suffix. Yeah, you commonly use the suffix "ol", like ethanol. And if we look at this alcohol's example here, 2-methyl-propan-1-ol. So if we count our carbons 1, 2, 3, but I've done it the wrong way round, as the alcohol is the functional group. You don't always count from left to right. So we're starting from alcohol and counting right to left. So 2-methyl-propan-1-ol. That's how you write it down. You don't go propan-1-ol 2-methyl, as methyl is considered to be a prefix to naming them. Now, if we look at 1,1,2,2 tetrachloroethane, if you have multiple atoms of the same on the same carbon group, then you just write down which carbon each atom is on twice in this case. So 1,1 means I've got 1 chlorine, 2 chlorine on carbon 1. And 2,2 just means I have 2 chlorine atoms bonded to carbon 2. Tetra meaning I have 4 chlorine atoms bonded in my entire compound. And ethane just simply meaning the rest is an alkane. This whole molecule is an alkane. It's just I have 4 chlorine molecules bonded to it. And then finally, going back to our simplest one, 1-chloropropane, 3 carbons bonded to 1 chlorine atom on the end. And that's as simple as you're going to get with the halogens. We'll look more at naming ketones and carboxylic acids as they come up in the textbooks, but for now, this is a good way to start out. So, if you go online and look up the Jmol application, you can have a little play around with the software like I have, jmol.sourceforge.net, and then you go to the download section, and then you click the direct download link. It will come up with a very big zip file. Then you're looking for the file called jmol.jar, so we'll wait for it to download. Okay, so once you download the Jmol file, you need the Java runtime in order to run it, as it's built on that runtime. And then when you click Get Mol, if you can't quite visualize it and you don't want to build a Molly mod because they take a long time and you might not have enough money to buy one anyway, or your college won't let you borrow them, then if you type in the chemical compound you want, so if I type in but1ene, the proper chemical name that you find in the textbooks or online databases, then it will come up with that molecule as long as you're connected to the internet and you're not connecting through any kind of internet proxy. For that you need to configure the proxy settings, but I'll go into that if people request it. So as you can see, there's a double bond here on the first carbon that ends at carbon 2, and then here and here, you have the other two CH2 group here and the CH3 group on the end. So this is quite a very good tool to play around with and have a look at molecules without even looking it up in your Molymod kit, trying to build it. So we'll move on to part 3 now. You can use the Jmol software any way you want. You don't have to install it. So if you ever are on a computer and you want to visualize it, then you can use that software. I will link in the description below, or you can go to jmol.sourcewater.net. But now we'll look at the formula of organic compounds. So a hydrocarbon was found to contain 85.63% carbon and 14.37% hydrogen. This is just the same as any other empirical formula that you've encountered before, but it only contains carbon and hydrogen. So if we pull away our screen, we have a look at our mole equations. Mass divided by molar mass equals 7.14, and 14.37 divided by 1 is 14.37. You do not need to calculate to do that. And then you work out your ratios. So you divide by the smallest number, 7.14. It'll be a 1 to 2 ratio. So therefore you only have one carbon atom and 2 hydrogen atoms, making it CH2 empirical formula. And knowing this, one can derive a general formulae. Now, a general formulae is the simplest algebraic formula of a member in the homologous series. If you're not terribly good at algebra and you don't really like it, then imagine that this is a formula instead. And if we substitute n equals 1 into the formulae, we will have one with 1 carbon, and then 2 times 1 plus 2, meaning this will make CH4 when you simplify it. And then if we substitute n equals 2 into it, make it n equals 2, C2H6. And then if we substitute n equals 3, C3H8. And then it keeps going in a uniform pattern, adding 1 carbon atom and 2 hydrogen atoms every time. So if we look at the alcohols one now, CnH2n plus 1 OH, and we can identify this one using the general formulae. So get this out of the way. If we substitute n equals 1 now into it, we can go C1H 2 times 1 plus 1, and that equals 3, so 4. This can't be CH4 OH. Yeah, CH3OH. Sometimes it can be represented like this, CH4O, which is why I wrote it differently. You can write it like that if you don't like the OH in the formulae. That's the simplest one, but you can really get you confused when it comes to the exam, so it's a lot easier just to write CH3 and OH. Don't put it in brackets, but it's a nice visual thing in your head to try and get acquainted with. So since I know it's going to have 3 carbons and we can stop faffing around, we have H 2 times 3 is 6 plus 1, so this will be C3H7OH, or alternatively it will be C3H8O if I was going to write it the other way, using just having a completely simplified formulae. So that's how to use general formulas in order to find out what it is. Alternatively, you could just look at the diagram, or when you don't have a diagram, a general formula is very, very useful. So we'll now go back and look at what we just learned. We learned how to name hydrocarbons back here. We learned how to name them with functional groups, and we also looked at different ways of representing formulae and calculating empirical formulas here. So I hope you found this tutorial useful. I will link to the Jmol application in the description if you don't really want to go on SourceForge and download the entire Jmol package, because it's about 50 megabytes and you only need this very tiny Java file in order to get all of it going. Anyway, this is a very good cheap free alternative to the Molly-Mod kit, although if you can get a Molly-Mod kit, I would strongly advise you to go and get one, because they are very useful. Anyway, thank you for watching and goodbye.